sugar farms. They were tapping a tree, and Jordan, seeing this happen, says, "My theory's wrong." She says, "Well, what do you mean?" He says, "You remember way back in the fall when we were studying about chlorophyll and leaves changing colors? My theory was the one that said the chlorophyll goes back into the tree and maybe is stored in tubes in there. Well, Patty, if that were the case, then the sap that's coming out of the tree should be green, and it's not. And so I need to go back and change that theory on the database." And so for Patty, that was an aha moment that realized that even though the learning officially about leaves had stopped, it didn't stop for these children, or at least not for Jordan. He was still grappling, it was still alive for him in his head. And so that brings us to knowledge building. It's simply the process by which knowledge is created. It starts with the natural tendency for children to play, I would say, and then play with ideas that maybe is not as natural. And then it extends to the unnatural tendency to deliberately improve upon them. I feel children, if you walk into a kindergarten classroom, grade 1 classroom, they all have wonderful, wonderful theories. That may not be the case, by the way, in a junior or intermediate grade. I think by then, if the children have not had this type of learning where we're interested in what they have to say, they learn very quickly the game of education. But so in early years, they have wonderful theories, but they're not necessarily interested in fixing them, revising them, and that's what knowledge building tries to do. It's a difference between learning for yourself also and learning for the community. We're very interested in developing a body of knowledge, a collective understanding, and that the community is responsible for. And it's very much a constructivist approach to education, where we are truly building knowledge as if it were something tangible. This creates, though, a radical shift, though. It means that the teacher now, I mean, we've had many teachers, and I was one of those teachers who considered, I consider myself a competent teacher, and then I had to explore what it really meant to be teaching, to be engaging every single child in the room, to be addressing every child's needs, every child's interest in whatever area of the curriculum we had decided on or the minute we were following in the curriculum. Now, a little bit about the technology. Knowledge Forum is basically a blank communal database that allows students to create their notes on and allows others to read their notes. I tried to do this type of teaching without technology because I'm always interested in can it be done without this expense? Can we make sure that everyone can do it? And I was actually only supposed to be at the lab school for a year or two. And so I thought when I go back, I may not have the same software, the same computers. And so I tried to use Post-it notes. And as you can see, it gets a little unmanageable. Again, children can produce incredible information, wonderful theories, but it's very different when you see what can be done here.
Welcome to Knowledge Forum. Knowledge Forum is a next-generation software environment based on over a decade of research by the CECIL project. CECIL stands for Computer-Supported Intentional Learning Environments. Knowledge Forum is about improving ideas. It encourages users to work jointly or on their own to contribute ideas and information to a communal database, creating a resource for the entire community. Ideas can be revisited, critiqued, built on by others, organized and worked in a variety of ways. To help you understand Knowledge Forum, we have combined real student notes to simulate a knowledge-building inquiry that would in real life occupy several weeks. Teams of elementary school students are studying the systems of the human body. We begin at the vision view, where students use a number of vision teams.
She's trying to understand how rods and cones help you to see, and her theory is that your brain needs to get involved before you can see color and depth. I'm going to build on this note. First, I'll write my theory. I'm working on the idea that the eye sees things upside down, and it's actually the brain that makes us see things right side up.
Knowledge Forum provides scaffolds that help learners to communicate both their ideas and the nature of those ideas to the rest of the community. These can be customized to suit different forms of inquiry. In this note, the student is using the theory building scaffold.
Now I'll add some keywords so people can find my note easily. I'm going to search the database for notes with keywords eye and brain.
The student uses the search feature to find all of the notes anywhere in the database with these keywords.
Here's a note from Marco. He's on the brain team. He's talking about photoreceptors and how the eye and the brain work together. I'm going to use this note as support for my idea that the brain and vision are connected.
The quote feature allows students to reference someone else's work in their notes. Selected information is added as a quote, and the bibliography is automatically compiled. A simple click takes you to the cited note.
This information about photoreceptors helps me understand more about the relations between the eye and the brain.
The student reads another note and makes another discovery.
Great. It looks like some people on the brain team are working to understand the visual cortex. We'll have to get together.
This sets the stage for further collaboration. As students build on each other's work, their efforts result in the increasingly elaborated networks of ideas that can be seen on a view. As students connect with different groups working in different views, they begin to realize how much different parts of the body affect each other. They decide to combine their knowledge and set a new goal for their research. To do this, they create a new view. They write their new goal, how do different parts of the body interact. Then they come up with the idea of creating a picture of the human body and linking all of their work to it. First, the vision group links their view to the human body view. The brain researchers link their work. And in this way, all of the different groups make their work available to everyone else. They then form new teams and began to contribute new ideas about how different systems of the body interact. While these students were actively finding connections with the ideas of their colleagues, other students were making a different kind of contribution by reflecting more deeply on their ideas. For more information about Knowledge Forum, please visit our website.
Just as a review, we have notes where children begin with a problem. I love the idea that they're starting with a question, and that helps to focus what the text of their note is. They're able to choose the scaffold supports that are off to the side there. This child has chosen new information, and so that again is helping to shape their writing. They're writing for a purpose, and those of us who have looked at language arts and how to teach literacy, this is so fundamental. Also, the idea that you can identify key words, that has a practical implication. You can search for any note that has that keyword, but it also helps with spelling. If you don't spell pupil correctly, your note is not going to turn up if somebody's doing a search. There's also an incredible graphic tool, and so students who would rather draw their understanding or their question than write about it can absolutely do that. There are new versions of Knowledge Forum allow children to absolutely simply download movies or create movies and then put them in their note, and different ways of expressing their questions and their understanding. And all the scaffold supports are customizable as well. I had children who said, I have difficulty with the term a better theory. At this point, I'm not sure that it's better, I just know that it's another theory. Can we add that? We have a discussion about it, and we actually added that. So we talked about the scaffold supports can be changed. When a child reads a note, the child can build onto the note, and they appear like that on the database. So the original note is dog-eared. I'm the author of that, and you can identify that because when I'm on the database, it's dog-eared up at the top. And then Frank has built onto my note. They are physically linked. When you open them, they look like this. If I quote something, or if Frank quotes something from my note, it's automatically footnoted. And so again, teaching children that that's absolutely appropriate. We want children to identify the source and get ideas from other places. There's huge problems in high school with plagiarism, but allowing children to understand why that's actually a good thing. Let's give credit to the source might help to prevent that. And then the notes are organized in a view. This view was designed by grade 4 children, and the children here were aware that others were going to come into this view to find information. And so there's sort of a title and a little paragraph and these subtitles, and the notes are organized, and there's some graphic elements to make it more appealing. Here's an example from a grade 3 classroom at the Institute of Child Study. The children went to High Park. They collected, I think, about 11 worms, and they had a worm composter in their room. They had many, many questions about worms, and it fit in beautifully with the curriculum. And as they started to chart their worms, they realized that by March they had over 2,000 worms. But they started to be very nervous because the worm count started to plateau. And so the question started to be about, was light starting to harm the worms? They went into the grade 4 database and asked the grade 4 students, what do you know about the impact of light on worms or other forms of life? And so extending the boundaries of the classroom walls. These are the views that the children created. So when I say view, what that means is if I click this, then a page would appear with many notes. And so it was amazing that the categories that the children came up with as a group in terms of how to categorize their questions, composting, classification, life cycle, and survival, when they moved on to plants, actually fit beautifully as well. So again, that's sort of an embedded assessment that the children identified what the big ideas were there and were able to transfer them when they were studying plants later on. And so they had many class discussions where children were really building on to each other and were shaped by the technology. For me, it's very interesting that at our school, children go around saying, my theory is, I need to understand. I have new information. That's an example of how the technology has helped shape the way they communicate with each other. I get very excited about that because for them it's absolutely normal. It's the way researchers think, but what's going to happen as these children grow up and have had all those years of experience? Here they are with their lab books recording information. Somebody spotted a worm egg and got very excited. They're reading texts that are way above grade level because as what we discovered was as children go deeper and deeper, material designed for grade 3 students isn't going to satisfy their needs. And so we needed to find ways to have children read a text that was difficult, but do that in a collective way. And lots of reading on the database. And ultimately, the children had thousands of worms and created a garden and actually did some work with the Children's Own Museum to share their knowledge with other children. Here's an example now from a public school in Toronto, a very unique public school, Rose Avenue. You can see some of their characteristics. And I'm going to let the child tell you a little bit about that. It all began with a dead pigeon, and just so that you have the context, they had a window that looked out onto, I guess, the roof of a gymnasium, and there was a dead bird that they couldn't access, but they could clearly see, and there were maggots on it, and the teacher thought, well, this is a perfect link to the curriculum, and started to study maggots. And here we'll hear the child.
It all started when Oksana found a dead pigeon on her way to the pet store. During our research, one big problem developed. We did not know which end was the head, the thin part or the fat part.
Of the maggots.
We discussed this problem a lot inside the database and outside the database until Sir Kale went to the internet and found a solution. Great, the thin part was the head. This was also my theory. Here's Sir Kale's note. I'll give you some time to read it.
You can see the child owning this.
Thanks. Can you call it? We wrote a lot of notes and created a lot of views in our maggot view. And this is our maggot view. As you can see, we have 6 views in our maggot view. Maggot existence, maggot habitats, maggot diet, maggot bird, maggot
They had strong stomachs, I guess. But you can see how deeply the children have gone, how invested they are in their learning. It's real, it's authentic, and most importantly for me, it's the children have learned how to learn. This knowledge, this process can be transferred to any curriculum. I've lost. There we go. So here are some close-ups of some of the notes that the children made. That picture probably was downloaded from the internet.